Welcome to the first virtual Battle of the Bridges. While this year the pandemic has made it hard for us to get together safely, we have still found a way to hold this event virtually. And I hope you're looking forward to a fun-filled activity of building a bridge with your friends and family. So let's get started. Here are some of the tools that you'll use to build your bridge. You'll see there are a variety of cutting tools, including scissors, knife, saws. There are tools for measuring, such as a ruler, calipers, measuring tape, and a protractor for measuring angles. You'll see there are also tools for sanding and filing certain pieces of maybe if you're using wood. And finally, there are some metal clips in the middle that can be used to hold your bridge together as you're gluing it and drying. Also, be careful, there are many sharp objects to be safe when you're using these tools. This is the testing stand we'll be using for your bridge. So you'll see there are two horizontal plates on top that the bridge can rest on. There are also two vertical plates extending downward from the horizontal plates. Those can be used as abutments for your bridge if you want to design something like an arch bridge. If you do that, please be sure to check the rules for the actual measurements between those plates to ensure that your bridge can fit between those plates. Also note that we won't be using the holes in the back of the test stands for being able to anchor down to this year. And so it'll be harder to do suspension bridge since we won't be able to use those anchor holes. Now let's look at all the different types of bridges. There's arch bridges, tight arch bridges, basket handle arch, suspension, cable stay, and truss bridges. But before we get into those, let's talk a little bit about the forces that are in bridges. There are two primary forces, compression and tension. So compression is when you're pushing on something. And you'll see on the left, if we push on something, how that sometimes, if it's long and slender, it will tend to want to kick out, or called buckle. And you'll notice that if you take a straw and you push down on the straw, well, eventually it wants to kick out or buckle. And so you can prevent some of that by applying braces. You'll see that in the figure in the middle there, how there's a brace in the middle to help the member that's now in compression from kicking outwards. So bracing can help prevent buckling. Materials that are good for compression include wood. You'll see that in your wood members, the shorter ones tend to buckle less than, say, some of the long, slender pieces of wood that you have in your kit. Then tension. Tension is when you pull on something, like a rope or a wire. This typically causes the member to lengthen, even can eventually snap. Materials that are good for tension include string, wire, and wood. Also note with string and wire that they're not very good for compression. If we try to push on them, they can't take any load. They just go slack. Also, connections are very important. These are some connections shown in buildings and bridges, but a lot of times our structures are only as strong. So as you're building your bridge, pay extra attention and importance to the connections. If you're doing a truss bridge, like shown here, you'll probably want to have some kind of plates at the joints that can be used to hold that joint together. In a bridge, we would call these gusset plates, as shown in the pitch green bridge there. You'll see they use bolts and rivets to hold the members to the gusset plate. While we may not have bolts or rivets, we do have glue. We can use that glue to connect our members at a joint to our gusset plates. Bracing. Bracing is very important for stability. So imagine this truss bridge shown on the left. There's a truss, two trusses shown in black, one on one side and one on the other. If we don't have bracing and we load the bridge up, the trusses are very unstable and will fall to one side and the bridge will want to roll over. as shown in the picture. To prevent that, we can use bracing, shown in the orange. That helps brace the two trusses together so the bridge behaves as a whole, and as we load it, the bridge will be more stable and won't want to roll over. Also, you'll notice in the truss bridge there are lots of triangles. Triangles are good, strong shapes and very stable. Here's a close-up of that bridge that wanted to roll over. It didn't have any bracing to prevent the trusses from becoming unstable. So please use bracing to prevent that from happening to your bridge. Now let's look at the types of bridges. So one is an arch bridge. We can see how if load is applied in the middle, that then the load is taken by the bridge in compression in the form of an arch. Those compressive forces are then transferred to the foundation of the bridge, whether it be rock or soil. And so these are all in compression. This is an example of an arch bridge. Next is a tight arch bridge. An example of tight arch bridge in the Quad Cities is the I-280 bridge and the Centennial Bridge. So, much like the arch bridge we saw before, as a car or truck drives over this bridge, the load is taken by these hangers that are in tension up to the arch. The arch is in compression, but the arch will want to tend to collapse and fall down. So to prevent the arch from pushing out and collapsing, there's a tension member connecting the two ends of the arch and making it stable. Notice how this kind of resembles a triangular shape, like we were talking about before. So in this bridge, the arch is in compression and the tie is in tension. Another version of the arch is the basket handle arch. You'll notice this from the new construction we have going on in the Quad Cities, the newly opened I-74 bridge. In this case, it's an arch bridge, much like the others, but to prevent or help with stability, the arches are inclined towards each other in the middle, so they come together and touch. This helps make the arches stable without having to use as much bracing. Another type of bridge is a suspension bridge. So in a suspension bridge, as a car or truck drives over the bridge, the load is picked up by these tension hangers into a big wire that spans from one tower to another tower. And the wire goes over the tower and again down to an anchor point at one end of the bridge and at the other end of the bridge. That wire is all in tension. And as the wire carries those loads up, to hold the wire, there are towers. And the towers take load and compression down to the foundation. So the wires are in tension and the towers are in compression. An example of a suspension bridge is the Golden Gate Bridge, and also our very own I-74 bridge, the old Green Bridge. Another type of bridge is the cable stay bridge. It's similar to a suspension bridge, where if a car or truck is driving over it, loads are picked up by cables that are in tension. It transfers these loads to a tower, which then transfers those loads in compression to the foundation of the bridge. An example is shown here. There is also one in Burlington, Iowa. Truss bridges. Truss bridges take load through members that are both in compression and tension. So let's look at how loads are transferred through a truss bridge. If we apply a load in the middle, there will be members that take the load in tension, which are shown in purple, up to the top of the bridge. Then the top of the bridge wants to get pushed inward on each other. So you can imagine the top of the bridge pushing inward, and so that's in compression. And then as we pull on the bottom of the bridge, it wants to get pulled outwards. And so the bottom of the bridge is in tension. So again, the members that are in tension are shown in purple, and the members that are shown in compression are green. An example of this are some of the train bridges around the Quad Cities, including downtown Davenport and the Government Bridge that connects to the Arsenal Island. Also, bridges can be creative. So as we know, bridges often become symbolic of their community, and creativity and imagination can be used to make the bridge look like something else. In this case, in Vietnam, they made the bridge look like a dragon. You can see they even added so that the dragon can breathe fire or also can spray water. And lighting can even change the color of the dragon. Now, after all the types of bridges we've looked at, can you tell what type of bridge this is? Okay, now we're finally going to start talking about some of the details on building your bridge. But before you build the bridge, you want to make sure you have a plan. And so take some time and draw out your ideas on paper. You can even draw your bridge out to scale or even to the real size of all the members, and you could use it as a template. All good engineers make a plan before they start building. Also, let's look at some of the rules for the bridges. So first, the bridge length has to be between 19 and 24 inches. Next, the bridge height has to be at least 4 inches tall. That's the minimum height. At a maximum, it can be 12 inches tall. That includes either from the top to the bridge deck or to the bottom if the bridge extends below or above the bridge deck, a total of 12 inches. The width of the bridge has to be at least 4 inches, but no wider than 6 inches. And there has to be decking across the entire length of the bridge, much like a regular bridge, to carry traffic. You'll see a white cardboard strip of paper that you can use as the deck of your bridge. The deck has to be capable of supporting a weighted toy truck, but it's only about 2 pounds. And then finally, the bridges will be judged on their structural efficiency, which is the maximum load carried by the bridge divided by the weight of the bridge. So if you have a really heavy bridge that carries a lot of load, it won't be as efficient as a light bridge that carries a lot of load. Here is an example of the toy truck that will drive across your bridge. Notice how the road can be bumpy, and that's a good thing from making the bridge lightweight and efficient. So here's some examples of different roadways. On the left, you'll see a good roadway that is light and efficient. You'll see it is kind of bumpy. On the right, you'll see a bad roadway in that it's very heavy and inefficient. So we recommend not doing something like on the right. Next, we'll talk about the load plate. So the load plate is where we attach the load to test your bridges. And so you'll see there's a plate that goes lengthwise along the bridge, and there's a hanger that extends below the bridge. Make sure to include a hole in the middle of your bridge for that hanger to go through your bridge. Now for a top view of the load plate. And so you can see here the top of the load plate and how there are members in the middle to support that load plate. This is really important. You want to make sure that you have a lot of strength to support the load plate. Some good things that we see here are that those tongue depressors that are spanning between the two trusses are transferring the load and bearing. So they're resting on top of the truss as opposed to if they rested below the truss. If they're resting below the truss, they would have to be held on by glue, and the only thing holding the load plate would be the glue, which isn't always very strong. Whereas in this case, the tongue depressors are bearing directly on the truss, which is very strong, and transferring those loads out to the strong trusses that were built. Another thing you'll want to think about is those tongue depressors are stronger when they're on their edge than when they're laying flat, as shown. So you may also want to make them standing upright so they're stronger. Either way, you'll want to make sure that you have a good strong portion of your middle bridge to support the load plate. And here's some examples of when there's good support for the load plate, like on the left, the bridge behaves all as one and we can test the bridge to its full strength. Example where there wasn't so much support in the middle, the bridge tends to the load plate just rips out from the bottom of the bridge and the bridge isn't really tested to its full potential. So please make sure you have good support for the load plate. Now, safety. Safety is really important. As we were talking about before, we have a lot of sharp objects and cutting tools that will be used to make your bridge. Always make sure to cut away from you and your body and away from your fingers. Also, when cutting something, sometimes it's helpful to put the piece you're cutting either in a vise or have a friend hold it so that no one gets hurt as cutting is going on. Also, we recommend eye protection as you're building your bridge and encourage wearing safety glasses. Also, the super glue is very sticky and it's easy to glue your fingers together. If this happens, we recommend that you have some fingernail polish remover handy, and that way you can put some fingernail polish remover on some paper towels and put them next to your fingers that are stuck together and let them soak in, and gradually you can pull your fingers apart. So again, the main thing is to be safe as we build our bridges. Now for some tips on using the glue. Use small glue drops. It doesn't take much glue to make a strong connection. Also, smaller drops dry much quicker and make building the bridge easier. You'll get 3 bottles of glue, but you'll want to use them wisely. Also, we'll show you some tips on opening and then also using all your glue. To open the bridge, we'll watch a video so you can see how to open the glue bottle.
Here's how to use Loctite superglues in the patented control dispenser. First, remove the packaging. Then, turn the cap to the right like you're tightening it until it stops clicking. That breaks the seal. Now, just remove the cap like normal. Turn to the left. To use the glue, I squeeze these wings on the sides. If I squeeze hard, I get a lot of glue. If I squeeze light, I get a little. It's very controlled, putting the glue exactly where I want it, with my fingers far from the tip. Plus, no runs or drips.
How you can get all the glue out of your bottle.
You can't get any more out of here, but you actually can. If you have a bottle like this, which is what this looks like in most cases in here, it's 2 brands, it's the gel and then it's the liquid. What you can do is you can squeeze the sides together and grab a hold of just the blue area and pop that out just like that, okay? Once you do that, then you want to put this in here and then you want to unscrew it and then remove it like that and then screw it back in, and then you have.
So you can see this is how you can take apart the outer bottle to get to the glue tube and use all the glue that's in the tube.
Your super glue.
And then finally, again, we just want to emphasize safety. So please be careful in building your bridge. Again, using good, safe techniques for cutting, and cutting away from yourself and your fingers. Also, be careful with the glue and have some of the nail polish remover, other safety equipment near you as you're building your bridge to make sure you can safely build. With that, good luck and have fun.